Conclusively, the data shows that the climate is warming in Alaska.
Volcanic gas emissions are increasing, and earthquakes near the volcano continue.
As officials warn, it is possible the volcano could erupt in a matter of weeks or months.
Glaciers all over the state are melting at a decidedly unglacial rate, beginning several decades ago.
Beneath the white silence of Alaska, beyond the sculpted peaks, the endless spruce, the ribboned rivers gleaming under low northern sun, a sequence of events has begun to unfold that has left scientists grasping for precedent and, at times, for words. Here, the border between Earth and ocean and ice is never fixed, and the ground itself has always devoured certainties. But in the spring and summer of 2025, it is as if Alaska decided to unearth its hidden history in a single, violent breath. This is no mere matter of trembling seismographs or the distant rumble of volcanoes settling into their ancient cycles. It is a convergence, a surge of volcanic gases hissing from the flanks of Mount Spurr, a massive void deep beneath North America expanding at a speed geologists once thought impossible, and newborn islands surfacing where glaciers have only just retreated. Earthquakes proliferate, echoing through the crust. Beneath the lakes, NASA satellites trace shifting boundaries where water now replaces vanished ice. As permafrost yields to warmth, ancient life, dormant for tens of thousands of years, awakens in the laboratory. What is really happening beneath the surface here? Are these mere coincidences, a string of unrelated anomalies, or signals of a far deeper mystery pulsing beneath one of the planet's last frontiers? Where does the story begin? And, more vitally, where could it lead? Alaska's story often starts in silence, snow falling in slow, stubborn curtains, cold pressing against the glass at field stations scattered across the state. But break that silence, and sometimes the land answers back with force. In late May of 2025, pilots with the Alaska Volcano Observatory flying reconnaissance missions above Mount Spurr noticed cloud columns flecked with grey, volcanic gases thickening in volume and colour, emerging from new fissures that only weeks ago had lain dormant. Scientists at the observatory scrutinized these plumes in detail, noting significant increases in sulfur and hydrogen concentrations, gases that, together with emerging traces of other compounds, hinted at deeper changes beneath the mountain's summit. Thermal imaging during those flights revealed anomalous hotspots encircling Mount Spurr's rim, mapping a complex and concerning pattern of underground heat. Routine observation became urgent around June's midpoint. Seismometers ringing Spurr registered earthquakes at ever shorter intervals, each one marking mounting tension in the bedrock. The last time Spurr erupted to catastrophic effect was 1992, when a towering ash column spread over Anchorage and beyond, halting air traffic and shadowing cities. But this sequence of activity was different in character and rapidity. Rather than sporadic tremors, the seismicity became persistent, forming what geophysicists recognize as harmonic tremor, a steady vibration pointing to magma on the move. We're not just looking at surface warning signs, explained Dr. Janet Schaefer at an emergency press briefing. What concerns us most is the interplay: gas, heat, seismicity. It's a pattern that often precedes eruption, and the chemistry of the gases suggests changes deeper in the magma system, not just superficial venting. In coordination with USGS and state emergency services, communities from the Kenai Peninsula to Anchorage reviewed evacuation plans and prepared supplies. There was unease, not just about immediate hazards, but about the deeper processes now underway. Had changes at Spurr signaled a wider adjustment in the entire Alaska-Aleutian volcanic arc? Was this a local event, or evidence of regional unrest tied to tectonic forces stretching along the subduction zone? For scientists, these patterns brought urgent questions. What had shifted deep in Spurr's magmatic chambers? Was this the prelude to a new blast, or only an episode in a cycle still far from its climax? There was no clear answer, only the raw facts of nature's restlessness, waiting for the next chapter to write itself in ash or fire. While attention fixed on Spurr, a second discovery emerged. This one buried deep within the mantle, where direct observation remains impossible, but signals can still be detected. Geophysicists working with data from seismic arrays across Alaska identified a newly detected void far beneath the North American plate. This void, potentially vast and clearly growing, slowed and distorted seismic waves from distant earthquakes as they passed through, suggesting material far less dense than solid rock. Satellite gravity measurements added another layer of evidence, indicating an anomaly that defied existing geologic models. Initial 3D maps, rendered from seismic tomography, depicted a zone that might span the area of several cities. Its exact nature uncertain, but its expansion cause for concern. Speculation among researchers ranged from possible pockets of partial melt or fluid to more complex phenomena involving tectonic processes. Some suggested that the void could represent a reorganization of deep mantle flow, possibly linked to the same forces now agitating the region's volcanoes and earthquakes. The unifying idea, Alaska's deep interior is more dynamic than previously imagined. There's a kind of clockwork to tectonics, noted Dr. Michael West, seismologist at the Alaska Earthquake Center, during a midnight broadcast. But something has disrupted the gears. When we see a void like this, we're not just looking at geology. We're looking at a process capable of altering everything above it. The volcanoes, the mountains, even the ecology across hundreds of miles. This anomaly raised sobering questions. Might this expanding zone presage a larger destabilization of the crust? Could the same deep processes explain both the agitation of surface volcanoes and the subtle system-level changes happening across Alaska's landscape? And if so, what lay at the intersection? Was there a single event or a cascade of consequences yet to unfold? While fire stirred beneath, the forces of water and ice continued to redraw Alaska's surface. In the remote basin of Alsek Lake, a landscape where sheer stone walls and glacier tongues meet icy depths, NASA researchers in June 2025 observed the birth of a new island. Satellite data and aerial imagery captured the moment as meltwater surged into what had recently been glacial terrain, exposing raw land never before mapped. Dr. Lauren Andrews, a NASA glaciologist, described the process with fascination. Melting glaciers retreated, and land long buried under ice emerged, revealing silts and rocks that had not seen open air for centuries. Within days, the newborn island became a focus of biological intrigue. Gulls and terns investigated its gravelly margin, and wind-borne seeds sprouted in patches of wet earth. This event at Alsek was not unique. Scientists across Alaska documented numerous instances where receding glaciers had uncovered fresh land and rewrote the coastline. These episodes were tracked in near real time using satellite monitors, drones, and field visits, confirming the rapid pace of landscape evolution in a warming climate. This is a feedback loop, Andrews explained. Glaciers melt, water fills the gaps, and land rises. Each change has consequences: new habitats, altered water flows, vulnerability to erosion or volcanic activity as pressure and weight across the land shift. The question persists: how will these evolving landscapes interact with the underlying tectonic and volcanic turmoil? Could land newly freed from glaciers experience more rapid geological change, from earthquakes to volcanic activity, as the weight of ice disappears? What new discoveries and hazards might these islands and lakes hold, unveiled in the wake of the planet's accelerating transformation? By June 15th, the seismic networks registered a second surge of activity, this time beneath Iliamna Volcano, an immense ice-cloaked summit at the northern head of Cook Inlet. Unlike its more spectacular neighbours, Iliamna had maintained relative quiet for decades. Suddenly, however, nearly constant seismic tremor replaced the previous pattern of sporadic earthquakes. The instruments at the Alaska Volcano Observatory buzzed with steady noise, pulse after pulse, almost unbroken for days on end. Dr. Michelle Coombs, senior geologist, described the phenomenon. What's unusual here isn't just the frequency, but the constancy. The volcano is almost never silent right now, not in the seismic record. The data suggested rising magma, gases forcing pathways upward, and fluids circulating through the fractured crust. This pattern prompted close comparisons with work at Veniaminof, another Alaskan volcano where research teams have developed models for stealthy eruptions. At Veniaminof, scientists uncovered how slow, subtle unrest, often missed by traditional warning systems, might build to larger, sometimes sudden events after months or years of warning. Not all eruptions begin explosively, Dr. Coombs said in a public lecture. Some announce themselves through low-level seismicity, a kind of background tremor that builds and builds. The only thing predictable is change. This suite of signs, persistent seismicity at Iliamna and Spurr, soil gas surges, and submarine tremors off the coast, sparked concern. Was Alaska entering a period of widespread volcanic unrest? Did these events represent isolated episodes, or were they interlocking steps in a larger tectonic shift? Alaska's greatest archive is its ice, which captures and protects a living past. As permafrost receded under the advance of summer warmth, researchers found life awakening after astonishing durations. In a summer lab near the Yukon-Kuskokwim Delta, Dr. Nisha Patel's team thawed a 40,000-year-old permafrost core. When the ancient ice yielded to warmth and moisture, dormant microorganisms stirred. Some began to move and metabolize. Genetic analysis revealed these organisms belonged to lineages adapted for extreme cold, with metabolic pathways optimized for low-energy conditions. Some hints suggested possible methane production or resistance to ancient viruses, signatures unique to an age when mammoths roamed Alaska. When we realized they were viable, that they could revive after so many millennia, well, we were speechless, said Dr. Patel. Similar revivals have been reported elsewhere in polar regions, but Alaska's ancient permafrost posed new mysteries about survival, evolution, and environmental risk. This awakening of ancient microbes is not merely a scientific curiosity. As permafrost thaws, it can release trapped greenhouse gases and, as recent studies demonstrate, revive ancient DNA and microorganisms. Each melted sample is a potential window into prehistoric ecosystems, and, as some experts caution, a potential vector for previously unknown hazards. What else lies waiting in Alaska's permafrost? Could these long-slumbering microbes reshape local environments, or even interact unpredictably with modern species? The answers remain unsettlingly open, written in every droplet of meltwater filtering through the ever-warming ground. The story of Alaska's volcanoes is not only one of local threat, it is a global tale. Eruptions here have left records in the stone, ash beds layered over millennia, datelines for geologists and archaeologists alike. And sometimes, the fallout has reached across the world. Researchers have connected one massive Alaskan eruption with global events, including a period of extreme cold and failed harvests in ancient Rome. Ash from Alaska, carried by jet streams, settled in distant ice cores, showing a direct link between high-latitude unrest and global climate perturbations. Tree ring studies and historical accounts reveal the breadth of the impact. Narrow rings indicating poor growing seasons, chronicles describing gloom and hunger. People often forget that what happens here, remote as it seems, can ripple outward to change climate, agriculture, even the arc of empires, said Dr. David Putnam, archaeologist and lead author on a recent interdisciplinary study. Evidence of ancient ashfalls is still found in Alaska's river valleys and beneath its forests, a silent reminder of nature's far-reaching effects. These past events frame today's mysteries in sharper relief. If Alaska's volcanoes can shade skies thousands of miles away, what might a modern eruption mean in our interconnected world? The interplay of local unrest and global consequence is no longer theoretical. It is a question with urgent relevance. On Alaska's coast, the uncertain boundary where mountains yield to the Pacific, another theatre of geologic drama persisted in relative obscurity. Submarine volcanoes, mapped only intermittently and monitored by scattered hydrophones, showed new signs of awakening. In early summer, teams working on the continental slope sought the origin of underwater tremors detected from Kodiak Island to the Yukon's mouth. Deploying remotely operated vehicles, they explored fields marked with fresh ash, gas seeps, and mineral-rich vents. The ocean floor, shaped by eruptions hidden from view, told a parallel story to the land above. Plumes of hot water and methane rose into the deep, feeding unique ecosystems and reshaping seafloor topography. Dr. Daniel Williams, a USGS marine geoscientist, explained some eruptions happen in the dark, stealthy, undetected by satellites or the human eye, but they reshuffle the ocean floor, release gases that fuel strange forms of life, and sometimes trigger tsunamis that reach distant shores. The sampling campaign confirmed a recent submarine eruption. Rare minerals were detected, and sediment layers bore chemical signatures only produced at extraordinary heat and pressure. These revelations tied the fate of land and sea together. Melting glaciers fed rivers that carried trees seaward, while volcanoes hidden beneath the waves shaped ecosystems and even coastal risks. Regionally, co-occurring signals, tidal shifts, earthquakes, and volcanic gas surges suggested the entire Pacific margin was restless. Seismologists watched patterns from Hawaii to Oregon, measuring tremors and eruptions that, while not connected in a simple cause and effect way, hinted at the complexity of Earth's giant tectonic systems. Amid these overlapping dramas, scientists searched for a pattern, a structure in the chaos that might explain the sudden simultaneity of events. At Veniaminoff, geologists honed models for stealthy eruptions, mapping how volcanoes sometimes operate in ways only illuminated by subtle, persistent signatures. Seismologists overlaid data streams, mounting unrest at Spurr and Iliamna, the mysterious void below, new landmasses on the surface, and revived ancient life from permafrost cores. Old assumptions about isolated volcanic systems gave way to a new vision: interconnectedness. Alaska's volcanoes, its shifting lakes, even the deep void all appeared linked by the vast and ceaseless churn of tectonic plates and mantle currents. Each eruption, quake, or retreating glacier formed part of a greater process. It's like looking at a symphony, with each instrument following its own score, except suddenly the melody has changed, said Dr. Schaefer, reflecting on these tumultuous months. What's changed in Alaska isn't just a volcano, or a coastline, or the air we breathe. It's everything, all at once. Rising gases, constant quakes, islands born from water, ancient life from the ice, and invisible voids expanding beneath the ground. Each the visible pulse of an Earth whose cycle is only now being revealed, one elusive mystery at a time. As another long day nears its sunless end on Alaska's western edge, researchers gather samples, check data streams, and gaze out over landscapes shifting before their eyes. An island glimmers where none was mapped last year. Steam whispers behind a shroud of spruce. Seismic traces ripple through ground both ancient and raw. To stand here is to accept change. For all Alaska's grandeur, recent events have underscored the deep interconnectedness of Earth's systems. Volcanic fire, glacial retreat, the subtle hum of ancient microbes, and the rumble of shifting crust, all entangled in an ongoing drama. The scientists, Schaefer, West, Andrews, Coombs, Patel, Williams, admit that answers are few and questions many. Is the growing void a sign of impending danger, or a natural passage for rising magma? Will Spurr or Iliamna erupt, casting ash over the land and darkening the sky as before? Do the awakening microorganisms bring new opportunities or threats? Are the new islands a close to a glacial era, or the opening chapter of a transformed landscape? Those attuned to Alaska's rhythms know the land is never still. Each ripple, each plume, each ancient cell whispers stories from deep time, messages not always easy to decipher. Across the centuries, Alaska has altered the fates of empires, shaded skies on distant continents, and shaped earth and memory alike. Ash and lava both destroy and renew. Melting ice hides, then reveal secrets. Tonight, above Mount Spurr, ash drifts on northern winds. Deep underground, the void grows. On a young island, birds scout uncertain terrain. And in a laboratory, a speck of life awakens, unseen for untold ages. Alaska's unfolding story is not only a warning, it is an invitation. To look deeper, to listen closer, to ask difficult questions. What else lies below, waiting for release or revelation? When the next unexpected event surfaces, will we see it for what it is? A beginning, an ending, or simply the Earth in restless motion, revealing truths as old as stone and sky?